Hello. Today I would like to show you the inertia dampener system that I have designed, how it works, what it does, and how to implement it. With this out of the way, let's get going. Okay, for this I'll be using my latest version of the Moonracer. This is a free blueprint. And the first thing I'm going to do is I'm going to be using my two accounts in order to show you two different perspectives of what is going on. This will allow you to see the difference between the system being on and the system being off. Now, as the name suggests, this is a racing ship. It makes it very light and having a lot of thrust. But even though it has those characteristics, I still have to overcompensate each time I want to turn in a different direction to cancel my previous momentum and acquire a new one. I'm now going to turn my inertia compensator, also called anti-drift system, on, and you'll immediately start to notice a difference, just how the ship looks, acts, and the way it pilots. So the concept is really simple. It's detecting the lateral movements and then it's turning on the opposite thrusters as hard as possible in order to prevent those lateral movements and compensate for me. This results in the ship acting just as if it was in a thick atmosphere, providing resistance whenever you are turning. So as you can see, when used properly, the system is really good. I am now going to show you how it works because there's quite a few things to do in order to get it to work properly. So here is my test bench ship, and as you can see, the system really is 5 range finders in total that work together. I'm just going to show you in a bit more detail how exactly it works and what not to do when implementing it in order to get it to work properly. So what I would like you to check right now is the way these rangefinders and cargo log work together. I suppose most of you are already familiar with the speedometer. There are, however, a few things to take into account whenever you want to use speedometers for an inertia dampener system. I'll show you in just 1 second. So here is a very simple Photoshop illustration I made just in order to show you the concept of how a speedometer works and how I'm using it for my inertia dampener. This is also going to show you the pitfalls of not implementing it correctly. So what's happening here is that you've got the real position and you've got the visible position. The visible position doesn't move at all, but the real position moves in the direction of the ship. This means that the greater the speed at which you are going, the greater the distance that is measured by the rangefinder, and through MoriWatari's video, we can see that with an equation you can get the real speed of your ship. This, however, also means that measuring lateral speeds is way easier said than done, and as you can see here, it can get a little bit tricky. So ideally, you need a very long cargo lock, and this would ensure that you get very lateral or vertical movements, but will still make it hard for diagonal movements. So now that you've seen the concept, you should understand a little bit better what happens with speedometers when you start turning all over the place. This, by the way, is an example of a bad implementation and what happens when you do not have the proper lengths. As you can see here, because of the real position of the cargo lock now having moved, those lateral movements are no longer being measured, and thus the inertia dampener cannot compensate for your lateral movements. So here's a little bit more information about the implementation itself. The speedometer's URL was modified. The original one runs in a 0.4 second configuration. I took that equation and I made sure that it ran in a 0.2 second configuration. This is important because it reduces the latency with which the inertia dampener can react and thus compensate for you. Here is the URL itself. What you're looking at right now is the left compensation. So whenever the right speed is detected, it is then multiplied by the horizontal force multiplier. This is one of the two levers you've got on your dashboard that allows you to decide if you want a very strong or weak compensation. It is directly proportional to your speed. And then it is checked if the speed itself is exceeding or not the minimum value that is used in order to trigger or not the anti-drift. This is done in order to ensure that you don't react to extremely small values, to misreading of the speedometers and so on. And then it's just your normal ordinary go-to in order to enable or disable the system. One last thing before I end this video, I would like to show you how I implemented it on the Moonracer. As you can see, the inertia compensator is a very bulky system. It not only requires a lot of space in order to be installed on your ship, it also requires a lot of space for the rangefinders to work properly. So what I did here in the Moonracer is I've set those rangefinders to aim in those tiny little gaps you can see in the side of the ship. This allows the rangefinders of the inertia compensator to still detect the real position of the cargo lock without having any issues in a compact space. This allows you to have a reasonably compact ship without having to deal with those rangefinders, and those pretty much implemented anyway. This concludes my video. Thanks a lot for watching, and I'll see you next time.